The James Webb Telescope has just unveiled a discovery so profound, so utterly transformative, that it threatens to unravel the very fabric of our understanding of the cosmos. For decades, the Big Bang Theory has stood as the cornerstone of cosmology, a seemingly unshakable explanation of the universe's origin. Yet the latest findings from this marvel of human ingenuity reveal a startling truth. The Big Bang, as we know it, may not hold the answers we thought it did. These revelations force us to confront a chilling possibility that our entire conception of the universe's birth is flawed. What could these discoveries mean for the future of science? How do they challenge the foundations of cosmology? And what new truths might emerge from the cosmic shadows? Stay with us as we embark on a journey to explore these groundbreaking findings, diving deep into the mysteries they unveil and the questions they ignite. The universe, it seems, is far stranger than we ever imagined. For generations, the Big Bang has been the bedrock of our cosmic narrative. It paints a picture of a universe born 13.8 billion years ago, emerging from a point of infinite density and temperature, a singularity where space, time, and matter burst into existence. This was no explosion into a pre-existing void, but the creation of space itself, expanding and stretching to form the vast cosmos we observe today. The evidence for this theory has long seemed ironclad. The cosmic microwave background radiation, a faint glow permeating the universe, is considered a snapshot of the universe's infancy, formed just 380,000 years after its birth. The redshift of distant galaxies, first observed less than a century ago, demonstrated that the universe is expanding, allowing scientists to trace its history backward to that singular moment. By rewinding the cosmic clock, researchers concluded that all matter and energy once converged at a point of unimaginable density. This elegant model has shaped our understanding of existence, offering a framework to explain the universe's evolution from its earliest moments. Yet it describes only the aftermath of the universe's birth, leaving the instant of creation itself shrouded in mystery. The James Webb Telescope, humanity's most advanced window into the cosmos, was designed to peer further back in time than ever before, capturing light from the universe's earliest epochs. Its infrared gaze can penetrate the dust and gas that obscure the distant past, revealing the formation of the first stars and galaxies. According to the standard model of cosmology, these first luminous objects emerged roughly 200 to 300 million years after the Big Bang, marking the end of the cosmic dark ages. Galaxies in their infancy were expected to be small, sparse, and slowly coalescing from the sparse matter available in the young universe. Early observations from the telescope seem to align with this picture, detecting faint, reddish galaxies from a time when the cosmos was just a few hundred million years old. These findings were celebrated as a triumph, confirming expectations of a universe gradually building its complexity. But then, something extraordinary happened, something that would shake the very foundations of cosmology. In a series of observations that stunned the astronomical community, the James Webb Telescope uncovered a collection of galaxies that defy all expectations. These weren't the diminutive, fledgling structures predicted by theory. Instead, they were colossal, teeming with stars, and astonishingly mature, existing a mere 500 to 700 million years after the universe's supposed birth. Some of these galaxies rivaled the Milky Way in mass, containing tens of billions of stars, numbers that should have been impossible given the limited matter and time available in the early cosmos. Researchers initially suspected an error, a misinterpretation of the data. But rigorous analysis confirmed the unthinkable. These galaxies were real, their light traveling across 13 billion years to reach us. The implications were staggering. For such massive structures to exist so early, the density of matter in the young universe would need to have been far greater than current models allow, perhaps 5 times greater. Alternatively, these galaxies form through mechanisms we cannot yet comprehend, challenging the very principles that govern our understanding of cosmic evolution. The discovery of these so-called universe breakers was only the beginning. The James Webb Telescope continued to unveil anomalies that cast further doubt on the Big Bang paradigm. Supermassive black holes, some exceeding 1 billion solar masses, were found in the early universe, far larger and older than theory permits. These cosmic giants should have taken billions of years to grow, yet they existed when the universe was barely a toddler. Elements heavier than hydrogen and helium, which should have formed only later in stellar furnaces, were detected in abundances that defy explanation. And then there's the Hubble tension, a persistent discrepancy between the observed rate of the universe's expansion and the predictions of the Big Bang model. The cosmos, it seems, is expanding faster than it should, suggesting that something fundamental is missing from our calculations. Each of these findings chips away at the certainty of the Big Bang, forcing scientists to question whether the theory can still hold under the weight of this new evidence. The implications of these discoveries are profound, shaking the confidence of even the most steadfast proponents of the Big Bang. If the universe's earliest structures form faster and larger than predicted, what does this mean for our understanding of its origin? The Big Bang theory, while elegant, has always carried unanswered questions. What caused the singularity to erupt? How could something arise from nothing? Why does the universe appear so uniform, with galaxies and radiation distributed evenly across vast distances? To address this uniformity, some invoke cosmic inflation, a hypothetical phase of exponential expansion in the universe's first moments. But inflation itself is controversial, lacking direct evidence and relying on complex assumptions. The James Webb Telescope's findings amplify these doubts, suggesting that the early universe was far more complex and active than inflation alone can explain. Could it be that the Big Bang, as we've conceived it, is not the full story, or perhaps not the story at all? This crisis in cosmology has sparked a wave of alternative theories, each more daring than the last. One such idea, known as the cyclic universe model, proposes that our cosmos is but one chapter in an eternal saga of creation and destruction. In this view, the Big Bang was not a beginning, but a transition, a big bounce from a previous universe that collapsed and rebounded. This cycle of birth, death, and rebirth would render the concept of a singular origin meaningless, suggesting a cosmos without beginning or end. Another theory, rooted in the multiverse hypothesis, posits that our universe is just one of many bubbles within a vast cosmic foam. Each bubble could have its own physical laws, its own history, and its own version of reality. In this framework, the Big Bang was merely the birth of our particular bubble, a local event in an infinite tapestry of universes. These ideas, while speculative, offer a tantalizing glimpse into a cosmos far grander and more complex than previously imagined. Yet the most provocative challenge to the Big Bang comes from the realm of quantum physics and string theory. Some theorists propose that our universe is not a physical entity at all, but a projection, a hologram encoded on a two-dimensional surface. This holographic principle suggests that everything we perceive, from galaxies to human consciousness, is a manifestation of information stored on a cosmic boundary. If true, the Big Bang might not have been a physical event, but the initiation of a computational process, a simulation crafted by forces beyond our comprehension. Such a universe could be the creation of an advanced civilization, one capable of harnessing the energy of an entire galaxy to power a reality so perfect it feels real to its inhabitants. The philosophical implications are dizzying. Are we truly free beings in a physical cosmos, or are we characters in a cosmic simulation, unaware of the code that defines our existence? These revelations from the James Webb Telescope force us to confront the limits of human knowledge. The Big Bang theory, once a beacon of certainty, now stands at a crossroads. Its elegance and explanatory power have guided cosmology for decades, but the universe, it seems, has more secrets to reveal. The massive galaxies, the oversized black holes, the unexpected elements, all point to a cosmos that defies our models and demands new explanations. Whether through cyclic models, multiverse theories, or the radical notion of a holographic reality, the search for answers pushes science to its frontiers. Each discovery brings us closer to understanding the true nature of the universe, yet also reminds us of how much remains unknown. The cosmos is vast, mysterious, and ever-changing, and our journey to comprehend it is far from over. The James Webb Telescope has not only challenged the Big Bang, but has opened a door to a new era of discovery. Its findings compel us to rethink the origin of everything, to question the very nature of existence itself. As we stand on the precipice of this cosmic revolution, one thing is clear. The universe is not a puzzle to be solved, but a mystery to be embraced. Its secrets beckon us to explore further, to push beyond the boundaries of what we believe is possible. What other truths lie hidden in the light of distant stars? What new paradigms will emerge to replace the ones we've outgrown? The answers may be out there, waiting in the vastness of space, ready to reshape our understanding of reality once more. The journey continues, and the cosmos invites us to keep looking upward, ever curious, ever awestruck, ever seeking the truth. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.